Hello guys, welcome to today's class where we're looking at another example on the distributive property. Now in this example we'll be considering our basic binary operations, that is our addition, multiplication and subtraction. We'll be trying to relate both of them because as we would have realized from the previous classes about distributivity is that we always deal with two different operations for each question. And then one thing we might need to know, one thing we should know is that the arrangement of the operations is actually needful that you take note of which one comes first and which one comes second. So we need to know which one is coming first, even if they are the same operations, which one is coming first and which one is coming second. So the arrangement of each operation actually matters in distributivity. We'll be taking an example now to actually consider that aspect also. Now we have an example here that says a set Z plus contains positive integers. Determine if the following basic binary operations are distributive under set Z plus. Now what we need to know is that we have different operations here. We are not giving the usual operation with the formula, but we know that these are basic operations that we know about: addition, subtraction and multiplication. So we can easily understand how to operate this. First of all, what we need to do, we need to bring out our set Z plus containing positive integers. You know, that is the universal set. That is the universal set containing all elements. Where our A, our X, our Y, and our Z are all elements of the set Z plus. So since they are all elements of set Z plus, we are considering these three elements under the set Z plus and then considering these different operations using the idea of distributivity. So for distributivity, for my figure 1 now, we have X plus Y minus Z. And we know for distributivity, we have to, using the idea of distributivity, we know that this should become what? It should take the first operation, we have X plus Y minus, then the second operation we have X plus Z. Using our idea of left distributivity. Now what we are now supposed to do now is to compare this left hand side and the right hand side to see if they are the same thing, if they will be the same thing after being simplified. So here we can know this is X plus Y minus Z. In the right hand side, opening these brackets, we have X plus Y minus X minus Z, which will give us X plus Y minus Z, as compared to X minus X here will cancel out to give us 0. We'll be left with Y minus Z. Now, having this, we know that our left hand side is not equal to our right hand side. So here I can say that the operation X plus Y minus Z is not distributive under set Z plus. So that's for our figure 1. Looking at our figure 2, what is the operation we have in our figure 2? We have X times open bracket Y plus Z. We have X. So we are using the multiplication operation first, and then the addition operation second. So from distributivity, you take the first value, the lone value, in the brackets with the first value here. We have X times Y, plus we also have X times Z. So we are going to check it out. If these two values are the same, that is the left hand side and the right hand side, see if these two expressions are the same, if they are actually equal to each other. Because we know that, let's not forget for our figure 1, because we discovered that the operation is not distributive, we need to signify that this and this are not equal. Its inequality here means that they are not equal and then therefore are not distributive. So comparing here, we know that expanding this would have X into bracket Y plus Z. Comparing the right hand side, we know this will be XY plus XZ. Opening this bracket, we have XY plus XZ. Comparing this one will be XY plus XZ. In this case, we realize that when the multiplication is first and then the second operation, which is addition here, is coming second, because the left hand side and the right hand side are equal, then we can say the operation is distributive under the set Z plus. The operation X times Y plus Z is distributive under set Z plus. We have done for the figure 1, we have done for the second one. Let's look at the third one. For the third one, we have X minus open bracket Y times Z, X minus open bracket Y plus Z, We have bracket y in this plot. Let's confirm. Our figure 3. We have y times z. For distributivity, you know, we take the first value, which is x in the brackets, the symbol, and then we take the first value here. We have y. Close our bracket. We take the symbol at the center, put it here. We take the first value again, which is symbol, then take the second letter. And then we try to compare and see if these two sides are equal. Opening the brackets here, I will have x minus yz equals to, opening the brackets here, I would have x minus y times x minus z, which will further give me x squared minus xz minus xy plus yz, which I can now say my x minus yz, you have x squared. And if you look at it, you realize that these two sides are different, are totally different. And because of their difference, it means that this is not distributive, because the left-hand side is not equals to the right-hand side. If the left-hand side is not equals to the right-hand side, then the operation x minus y times z is not distributive under set z plot. So in the next class, we'll be continuing, we'll be solving for the remaining 3 examples that we have there, and we'll be trying to see how we can actually express this as either a distributive property or not as a distributive property. But I would enjoin all of us to actually try that so that we can have our own answers before the class and then compare and see where we have made our mistakes. See you next class. Have a nice day.